Hello guys, this is the Smart Chessboard project presented by Izat and Christian. We will start off with the agenda for this presentation, where we will start talking about the project goals, the design, testing, challenges, and current state of. Starting off with the project goals, we are to build two boards capable of detecting magnets at any square. We will use LEDs to display possible moves and moves made by opposing players. We are to connect the boards of our server to allow players to play from remote locations. And lastly, we would want to create a unique and immersive player experience. Moving on to design, we will print the 3D board top. We will also print 3D chess pieces with magnets attached to each piece on the bottom of it. We will use Hall effect sensors that will be placed under each square of the board to be able to detect any magnets. We used 4 16:1 multiplexers, and we will use them to cycle through the board to detect those magnets, and an addressable LED strip where one LED will be placed under each square to light up the squares as needed. And to show you some of the design progress that we made so far, we already printed the board top. We also connected all of the Hall effect sensors to the bottom of the board. We connected all of the LEDs to the bottom of each square on the board as well. And lastly, we have the connection for the breadboard. If we look closely at that breadboard, we will see how we connected the multiplexers. We connected them in a way where we only use 9 pins. That is, we're using shared select pins as well as a shared multiplexer output pin, and then a separate enable pin for each multiplexer. We activate each multiplexer one at a time to read through them. The last picture we will see is going to be the serial monitor reading through the boards as we are placing magnets and changing their locations as well. As for the testing of this project, you will see that we began testing the board with only one line of Hall effect sensors, where these halls are connected to a multiplexer. It can detect the magnet and turn on the corresponding LED. As for the second video, you'll see that we expanded this to where all the multiplexers are connected and they are reading the entire board, so we can detect the magnet on. As for the testing of this project, you will see that we began testing the board with only one line of Hall effect sensors.
Hello, my name is Christian, and I'll be covering the challenges and the current state of this project. As for the challenges, we viewed all of our challenges coming from one of two main categories, software and hardware. As for our software challenges, we viewed the main challenges to be generating code that reads all 64 Hall effect sensors situated underneath the board, as well as the software to compute all the possible moves depending on the type of piece that the user picks up. Lastly, for software, the communication between the two boards would be a major challenge. As for hardware, the assembly and the wire management of all sensors underneath the chessboard would be the main hardware challenge, and the last would be the power management to power all of the LEDs, 64 sensors, and ESP32. As for unexpected challenges, we ran into a lot of difficulty connecting the ESP32 to our individual laptops, which required a lot of troubleshooting time. And lastly, the last unexpected challenge was the board assembly itself, with a lot of soldering and wire management. It was definitely difficult. As for the current state of the chessboard, the software is mostly complete, with the code for reading all current sensors complete and functional. as well as the code for calculating the available moves complete. However, that has not been put up for testing. Lastly, the server code for the ESP32s has been complete. However, the client side is what has not been added yet. As for the hardware, all of the sensors have been wired and are all functional, and the whole board can be read, and the LEDs have been wired with some slight issues due to power supply management. Our multiplexers are all wired and functional, and the board is functional as it pertains to reading its current state.
Thank you.